part 3. In the last class, we learned about the definition of quality, and we have also seen the popular view and the professional view regarding the quality. One is the popular view, in which we tell that the quality cannot measure. Then we came across the professional view, and we also saw the two-level concept of quality. Just for a glance, the two things are important, means two definition: the conformance of requirements and fitness for use. The Crosby has defined the quality in the professional view. One is the conformance of two requirements, and another is the fitness for use. These two definitions are related and consistent. And we also saw two-level concept of the quality, in which we have got two things: the customer satisfaction and the producer's adherence. These two make one loop, isn't it? So there is a closed loop. When these two work in hand, definitely we are getting the quality product. Today we will see about the software quality. When we talk about the software quality, the first thing that will come in our mind is it should be bug-free software. Whatever product we are getting, it should be bug-free. So what is that bug? Bug has got a general meaning, but when we come across this software, bug is nothing but failure or flaw in the software program. There may be so many reasons from which the failure occurs, but what is a bug? Bug is nothing but it is a failure or flaw in the software program. The narrowest sense of the program quality is commonly recognized as lack of bugs in the product. It is also the most basic meaning of conformance to the requirement, because it is the software that contains too many functional defects, isn't it? When we are developing software, there are so many functions. So one function is not working properly, means there is a functional defect. The basic requirement of providing the desired function is not met. The main purpose, the very purpose of the function is not met. We are calling it as a failure, the functional failure. This definition is usually expressed in two ways. We have got two terms. The first is the defect rate and another is the reliability. What is defect rate? Defect rate is number of defects per million lines of the source code, LOC, line of code. So how many defects are there in that code? That is, we call it as a defect rate. The second thing is the reliability, isn't it? Number of failures per and hours of operation. That is mean time to failure or the probability of failure free operation in a specified times. The reliability, what it tells, it takes the time into the account, how many times the software has been failed. So for so many hours, for so and so particular time, how much it has been failed, that we are going to measure the reliability. So what does it mean? It means that it should have the least defect rate and it should have the highest reliability. Means there should not be any defects in the line of code, LOC, and the reliability should be higher, so that it should very less number of failures should occur in a system. So the customer satisfaction. So what for these two, defect rate and reliability, so that we should gain the customer satisfaction. The customer satisfaction is usually measured by percent satisfied or not satisfied, isn't it? So there are two things: either the customer is satisfied, either the customer is non-satisfied. Not satisfied, you can tell neutral or dissatisfied. From the customer, how we are getting it? We are having the customer surveys. To reduce bias, techniques such as blind surveys, the interview does not know the customer does not know the company. So we will have a blind survey so that the third party will come into the picture and they will take the survey, so that it should accomplish it in an unbiased way. So after the all, usually so many attributes they are being gauged, it means we are measuring so many attributes. For instance, the IBM monitors satisfaction when its software products are at the level. So we have got one model, we will discuss in detail the CUPRIMDA model. CUPRIMDA model. So here it is there. Yeah, CUPRIMDA. CUPRIMDA model, you can tell. What it tells, it takes into account into seven attributes or seven parameters that are related with the software quality: capability, usability, performance, reliability, installability, documentation, and availability. So the IBM, what it does, it takes all these parameters into account so that it want to measure the quality of the product. So usually they take into that all these parameters. So this HP Hewlett Packard, it also focuses on few more parameters. So every company, they, if they want to gauge, if they want to measure their quality, they have they have set their own parameters. HP, they focus on the functionality, the usability and reliability, the performance, serviceability, isn't it? So depending upon their the company, they have their own standard tools to just to measure the quality of the product. So coming back to this point, so the whole thing, what we need to get, we need to get the customer satisfaction, to increase overall customer satisfaction as well as satisfaction with various quality attributes. The quality attributes must be taken into account in planning and design of the software. It is very obvious, isn't it? So we have to take in the planning itself all the things we have to take into our account. However, these quality attributes are not always congruous with each other, means they are all not matching with one another. For example, the higher functionality complex of the software, the harder it becomes achieve maintainability, isn't it? When we talk into practical scenario, if we have the functionality, the higher the functional complexity, the more the functional complexity is, the harder it becomes to maintain achievability. The more the software becomes complex, the more harder it becomes its maintainability, isn't it? To maintain it, when it is a product itself is a complex, then to maintain it, obviously it will be very much complex. Depending upon type of the software and customer, different weighing factors are needed to different quality attributes, isn't it? The softwares are different, the needs are different, the customers are different. So we cannot have a single standard, isn't it? So many parameters are there. For large customers with sophisticated networks and real-time processing, performance and reliability may be more important, isn't it? For some specific application, some real-time application, reliability may be much more important, whereas documentation may not be required, isn't it? So depending upon the type of the software and the need of the customers, so these the attributes will get more priority or less priority. For customers with standalone system with simple operation, on the other hand, ease of use, installability, document may be more important, isn't it? When we talk about a single standalone system, what we need is, we need that there should be easy installation, isn't it? So that's why one parameter may get more priority depending upon the usage. So we have got one more important. So this all just now we saw that for a software with diverse customer, therefore setting goals for the various quality attributes to meet the customer requirement is not easy. So CUPRIMDA model is there, in which we are dealing with the seven different parameters: C for capability, U for usability, P for performance, R for reliability, isn't it? So I for installability, and documentation and availability. Documentation and availability. M for maintainability. I forgot to write it. M. So M for maintainability. How we are going to maintain the software. So these are the eight, 1, 2, 3, 4, 5, 6, 7, 8 parameters are there. So when we come across, see, when we talk about a practical scenario, there may be different softwares, there may be different products. For the large customers with sophisticated network, real-time performance, reliability may be more important, isn't it? So for the customers with the standalone, we need easy installability may be more important. So in this figure, we have shown the interrelationship of the software attributes. So how we are, the figure shows the possible relation of some quality attributes, isn't it? So what is the possible relationship between the some quality attributes? Some relationship are mutually supportive, some are negative, and yet others are not clear depending upon type of customer and application. See, we cannot have a single rule for all the products because the customers are different and there are various applications. So finally, what we are telling, some relationship means the available all these parameters, isn't it? So some relationship are mutually supportive. One parameter is supporting the other parameter, and some are not supportive. Some relationship are mutually supportive, some are negative, and yet others are not clear depending upon type of customers and application. For a software with a diverse customer set, therefore, setting a goals for various quality attributes and meet the customer requirement is not so easy, isn't it? So see here. So when this black dot is come, it is a conflictive. So if it is not just without the dark, only a circle is there, it is supportive to one another. So it is nothing means it is a blank. So we cannot have so for a particular software. So one parameter may not be supportive to the another parameter, isn't it? Just now what we discussed that when the complexity of the software becomes more complex, definitely there will be problem with installability, maintainability, isn't it? To install a complex software, it becomes obviously, yeah, it becomes a tougher task. So one parameter may be supporting to another parameter, or one parameter may not be supporting, means it becomes a conflict, isn't it? So one thing, if you want to increase, the other thing will decrease, isn't it? So it may be something like inverse proportional. So same thing is being shown, the interrelationship of the various software attributes using this CUPRIMDA model. CUPRIMDA example means we are taking all these 8 parameters into account. We are telling that in one particular product, one parameter may be support to another and one parameter may not be supportive to another. See, when we come across this, the development process that does not address requirement quality is bound to produce poor quality software. What is the whole crux, isn't it? The whole development process which does not address the requirement quality, isn't it, is bound to produce, obviously it is bound to produce a pure quality software. So this is one view, and we will see the next view. Yet another view of the software quality is that the process quality versus end product quality, isn't it? I have marked in yellow so that the process quality versus end product quality. From customer requirement to the delivery of the software product, the development process is a complex and often involves a series of stages with each feedback paths, isn't it? So it starts from the requirement of the user and it ends to whether he is satisfied or not. There are so many stages. So in a practical scenario, what is happening is the whole development process. So when it becomes so much complex, there should be a series of stages, isn't it? There should be a series of stages and each stage should be provided with the feedback path. If we get the feedback path, obviously we are going to rectify ourselves, isn't it? So the whole process, let it may be a complex process only, but when we have got different stages, when we have got the facility of feedback from every stage, such that we can come up with the software by taking all the feedback, so that our software will be much more quality product. So that's the thing we are going to I think you might have learned how we can get all these things, isn't it? Definitely one model is coming in your mind, that is a waterfall development model, isn't it? We will see it From customer requirement to the delivery of the software products, the development process is a complex and often involves a series of stages, each with feedback paths. In each stage, an intermediate deliverable is produced for an intermediate user of the next stage. So we have got this simplified representation of the waterfall development process. I think you might have studied all this in the earlier classes. We have got the waterfall model in such a way that system requirement specification, software design, software implementation, software integration, formal process, and maintenance and operation. The whole process has been divided into so many stages, and each stage has got a feedback path, so that at every point we can rectify it. So what it tells, if we intend the concept of the customer in the definition of the quality to include both external and internal customer, the definition also applies the process quality, isn't it? Finally, we are getting the we are reaching the quality. If each stage of the development process meets the requirement of intermediate user, isn't it? Different stages are there. The end product thus developed and produced will have the specified requirement. This statement, of course, is an oversimplification of reality, because in each stage numerous factors exist that will affect the stage ability to fulfill its requirement, isn't it? So the whole process model, the whole waterfall model is developed in such a way that we have got different stages, and each stage we are getting the feedback, and we are, after getting the feedback, we are rectifying it. So we need measures of the characteristics and quality parameters of the development process and its stages, as well as the metrics and models, to ensure that the development process is under control and moving towards the product's quality objectives, isn't it? The whole thing, we are moving in a such a direction that we want that the objectives of the product quality should be reached.